All right, so we're back for just a little bit. I won't actually be walking through News Site 3 with you, but I will go over the concepts that you need to know in order to get through to News Site number 3. So News Site 3 relies on News Site 2, News Site 2 relies on the News Site 1, so on and so forth. I want to go over a few just key concepts before we get started. What's a React component? I want to go over a few things. React component, what is state, props. Maybe these three big things are things that we need to know. So tell me all that you know about a React component.
So React components are basically the various sections of the document of the actual page.
Cool, I like that. All right, so it's what does it return to you? Like, what does a React component? What it just returns some sort of markup. That's correct. Yeah. So you can think of this as like reusable code. It returns markup.
It's markup.
HTML. Could be XML. Could be Markdown. Like these are all they're called markup languages. Those are ones that just show something out to the page. So each React component has its own state and its own behaviors. Let's talk about state. What is state?
State is basically the attributes of each component.
I like that. I like that. That works for me. It's also pretty much like how something is. You can think of this as like on versus off. You can think of it on as like selected, not selected. It's how something is on the page. Like based off of are you logged in or are you logged out, that'll change the state of your entire application. Does state live in like a globally, or does it live on each individual component? Okay, lives on each individual. Okay, let's talk about props. What are props? This should be the easiest one.
Values that are passed down from
Yep. Properties, aka parameters. Things that you more or less pass from one component to another. And so those are the big concepts. React is just a reusable bit of code that just provides markup. That's all it is. So you only have to type in the article teaser thing one time, and then it's going to push out to the screen the way that you expected to see it over and over again. It's just reusable code. Each React component has its own state, has its own behaviors. Like the behaviors are the methods that it can do. Like it takes some data, it may alter it in some way, and then display it out to the screen. That's all React component is. Each React component has state on it, or it could have state and it could have props. State is basically how something is. Like when you clicked it, you turned the state of your particular component on, or you turned it off, or something like that. State it's one thing that we forgot. It's a hash that lives on each component. No, it's not a hash. It's a JavaScript object. Object that lives on each individual component, and you can put whatever you want inside of it. It's just kind of like a black box that you have. Then props are basically properties, things that you're passing down from one parent, or like not even one parent. You're passing it down from one component into another component, and you can be passing things back up. That's where that super comes from. So we have our completed news site number 2, and up to this point, like if you remember, we were just doing stuff with app.js. Where is my article teaser? Article list, there it is. We were just bringing in a whole bunch of, where are my, this.props.articles. What is calling article list? It's home page, sorry. Right now, we've just been reading news directly from a JSON file. It looks a little something like this. And this is kind of more or less to be expected. It's all the crucial information that you need separated by different key value pairs. So it's kind of like the abstract is an important piece of information that you need. The created date is an important piece of information that you're going to need. Right now, we're just reading from, like you see here on line 3, we're just reading it directly from one file. But in like a typical full stack development team, you're going to either be, so when they say full stack developer, that means someone who is just as comfortable doing stuff on the front end, like JavaScript and React and other things like that, HTML and CSS, as they are on the back end. So we're talking about Ruby on Rails, so we're talking about Java, we're talking about Python or something like that. So a full stack developer can basically take everything from how the website looks and functions to the data. I'm handling the data, I'm sending it off to this service and that service, all the way down to even setting up the servers and everything like that. Full stack developer generally is a term that has been thrown around in the past as someone who we're going to pay a decent sum of money to do everything. So instead of hiring 3 separate people, one for front end, one for back end, and one for like DevOps kind of thing, we're going to pay one person a smaller amount of money to do that, because it might take 90,000 per person. We might be able to pay this person 105 and they can do everything. That's what a full stack developer is. If you're going to be a full stack developer, try not to get stuck there for terribly long, because that generally means you're probably underpaid. But you generally speaking, what happens is some people truly are full stack, and those people are kind of like unicorns that you want to have on your team. But more likely than not, you're going to be either a front end, back end, or a DevOps engineer. You're probably going to get pigeonholed into one or the other. You kind of, or maybe after this week, you'll figure out, do I want to be a front end dev? So it seems like, Aaron, you seem to like front end stuff, and it clicks for you, and and for other people, like they're just like, I don't like React, I don't like JavaScript, I just want to do like Rails kind of stuff, and they're more going to be geared towards back-end things. Other people are like, I want to set up AWS servers all day and learn about Nginx and like configurations for servers and things like that. Those people are probably going to move towards DevOps. But in a typical full-stack development team, you're going to have a front-end engineer and a back-end engineer working very closely together. The front-end engineer is basically going to say, like, what data are you sending me? What kind of format are you sending that data in? And like, I will make it look nice. I will make it go on the page as expected. The back-end person is basically in charge of, let me talk to the database, format it like this for you, and then I'll just give it to you the data, and you can do whatever you need to do with it. I'm much more in that camp of just like, I'll go in the database, grab whatever you need, format it however you want, and give it back to you. Like, I don't want to touch the front end at all. That's not the best way of going about it, but that's just kind of how I am sometimes. So today's challenge, when it comes to news site number 3, news site number 3 is not a ton of React code. Instead, it's mostly using AJAX, so asynchronous JavaScript and XML, to get some data from an external website and bring it back into our app to be presented in a React component. So once we get it, you're going to use your homepage and your article list components so that you're no longer using this internal data. So to understand this a little bit better, I'm going to comment all of this out. Throw this to the bottom. Understand this a little bit better, we have to understand a concept called promises in JavaScript. So we're going to start with something that just says that's just basic AJAX. So I have jQuery, this $sign in the front, and I'm going to use their AJAX library to make a request to JSON IP. This is being sent in the background. I don't have to wait for it to happen or anything like that. It's just going to send when there's some time that's free. So AJAX stands for asynchronous JavaScript and XML. So I start off on a web page. I make a request to this particular thing. And if it's successful, I will do something with it. If it's not successful, I will say that something went wrong. Maybe I'll just console log the data. And if that goes well, then I'll console log it. If not, I will just put it out. Oh, have an alert that says something went wrong. So I'm going to just do this. AJAX is not a function. How do I get jQuery in here? Well, you kind of get the idea. This is kind of like that review of the AJAX. I make a request in the background to this particular URL. If it's successful, the data that I get back, I'm just going to console log. If something blows up, then I will just say, hey, something went wrong. It's not a terrible way to fetch your data and do something with it. But at first, Ajax at its core was just meant to grab data from like weather widgets or like stock widgets and then bring it back onto your web page. But as the internet grew, it became a little bit more unmanageable. So let's talk about like maybe a hypothetical example from Facebook. Let's pretend Facebook was using Ajax. Let's say you're trying to log in. So I'm going to make an Ajax request to facebook.com/login or something. I don't know if this is actually what it is. If it's successful, I'll do something. If it's unsuccessful, I'll do something wrong. But let's talk about what happens when you actually finish making a request to facebook.com/login. There are, like when you log in, you hit the home screen, you probably have a bunch of posts. And then you have a bunch of photos, probably a bunch of statuses. And eventually what's going to happen is your code might look a little something like this. So I make a request using Ajax to facebook.com/login. If it's successful, then I want you to load all the posts. Once the posts are loaded, I want you to load all the photos. Once the photos are loaded in, I can actually continue this. This can actually continue on quite a bit. You have likes, something like that. Something went wrong with post likes or something like that. So this kind of looks like a giant Christmas tree of doom. They called this, like if you look at older code bases with JavaScript on them and you're using a bunch of Ajax, what you'll notice is it looks a little something like this. They call this the JavaScript Christmas tree of doom, or what more affectionately people call JavaScript hell, because you don't know at what level you've broken. So I log in. If it's successful, then I'll load the posts. If the posts are successful, then I'll load the photos. If the photos are successful, then I'll load the comments on the photos. If the comments are successful, then I'll load the likes on the photos. And this can go down like many, many different layers when you think about something like Facebook. And if anything blows up, there's an error here, there's an error here, there's an error here. Like you have to chase down every single bit. And this is just like 4 or 5 layers deep. In reality, there's probably like 8 or 9 different things happening in the background. So you could have, in order to make one Ajax request, you might actually end up with like 17 different requests to get what you want at the very end of things. So this is how like old school JavaScript, like in old school like Ajax was made. And we're going to look into like the more modern way of writing this. So just kind of remember JavaScript Christmas tree of doom, JavaScript hell, whatever you want to call it. It's just like many different layers of hell as you're going in and you're going out. So let's take maybe we'll do like a real world example. Let's pretend that you are, your house is a website. So I got a function. I call it get new carpets for living room. So let's say I'm making an Ajax request, like a real world example, not like actual code. Like let's say I make an Ajax request, like I'm going to buy carpets online for my house. So when you purchase something in real life, you go online to some place and you put your credit card information in, and you press enter. You press place order, and then you just wait. You don't know what's happening in the background, nor do you really care. You go on with your day, and then in 2 to 3 days, maybe a week or something like that, you look outside your door. There's all these carpets that are outside of there because of those are the carpets that you ordered. So if you think about it, when you talk about buying carpets online, it's an Ajax request. You make something happens, you press the place button, and then you just wait. If it's successful, once it's delivered, you're going to place the carpet in your living room. You're going to say, "I love my new carpet." That's something that you might say or do. If something blows up, and like maybe there's an error with this Ajax request of buying carpets online, you might not have enough. You might have ordered a different color. You might have ordered a different like thickness or something like that. You just call customer service. So this is like a real world example of like buying stuff online using like the concept of Ajax. So instead of using Ajax, which is the old school way of doing things, we're doing something called fetch. Fetch is the API, like the newest and great, not the newest and greatest. It's an updated version of Ajax. Ajax happens in the background. When you read it, it goes all the way down like this, and then like you have to worry about success cases and then error cases, and then it's very, very difficult to read. If you remember the old days, like we go back just a few bits, like this is what old school making requests in the background look like. Nobody wants to read this. So what they ended up doing is they created what's called the fetch API. So fetch basically says, I'm going to do something and then just stop. I don't need to worry about success or failure cases. If you want to create custom things, then you can. But let's say like we're building a house. So the first thing that what we do is like the whole thing would be build house. So once we build the house, then we're going to make another fetch request to frame the house. Then once that's finished, we're going to do the HVAC and electricity. And then this allows us to have code that reads top to bottom rather than this thing. This one you have to worry about, like if something breaks over here, what layer I'm in, what layer am I in? So I have to like guide this all the way up. Okay, I'm talking about this particular Ajax request. But by having this newest thing with fetch, you're able to read asynchronous code from top to bottom. This still does the exact same thing, but it looks a little bit different.
What happens if the frame of the house is rendered?
That's a great question. We're going to get to that in just a bit. So let's pretend for a second that you're buying a house or you're buying a condo. Unless you're like super baller or and should not be here at like Code Platoon, you probably don't have $100,000 to $300,000 to put in the bank to pay for it out of pocket. You're likely going to take a mortgage out. So you go to a bank, and they will provide you a promise that they can loan you $200,000. You don't actually have the $200,000 in your pocket when you go visit the bank, but they give you a little note from the bank that's basically a promise, and then you hand that to your realtor or you hand that to the seller of the house saying like, the bank has guaranteed me, they have promised me that they will loan me $200,000 to buy a house. You can make a contract with the person in the future that basically says you're going to have the money in the bank to pay them at some point in the future. JavaScript promises look a little something like that. So we're going to build this house. Instead of using fetch, we're going to use promises. So we have a function. It's called build foundation. We don't need to build the foundation right away, but what we're going to do here is we're going to return a new promise. A promise is basically a guarantee that something is going to happen sometime in the future. The guarantee takes in two things, a resolve and a reject. Resolve means it's successful, reject means that it's not. So I have a timer here that basically it's going to set it to 1 second and then just basically either successfully run it or unsuccessfully run it. So here, when we run build foundation, we're basically saying we're using this concept of promises, saying once the foundation is built and the promise is executed, after that, then we're going to console log the foundation is built. Let's see this run in real life. Let me just grab this first one here, so make sure this doesn't blow up. So I have an undefined function called build foundation. I'm going to build the foundation, and then I'm going to, after that is finished, I'm going to get a promise here as a result, and then it's going to just console log foundation built. Grab this here. Missing a parenthesis after the argument list.
It's inside the quote.
Good call. So you can kind of see what's happening here. So what's happening is I'm building a foundation. When I call build foundation, the first thing it does is it returns me a promise. The promise is basically saying, I heard you. Like I acknowledge that you sent this request, and I promise you that I will actually do something in the future. So what I'm listening for is kind of like what I'm listening. We're going back to the laundromat example, right? I go to the laundromat, I drop off my clothes. They give me a receipt. That receipt is a promise that my clothes will be ready by X time on Y date. I don't care what happens afterwards. So it's basically drop off stuff. They return me a promise, a receipt. Drop off my laundry. They return me a receipt. And then afterwards, I will say, like, my laundry is clean. I don't care what's happening underneath the hood. That's Build Foundation's job. But for me, all I care about is I get a promise back. Promise saying, like, I guarantee you I will do this in the future. And underneath the hood for them, it's basically saying, I'm going to wait 1 second and then just resolve it. After it's resolved, then I write the foundation is going to be built. So let's create a bunch of promises to build this particular house. So first things first, has anyone worked in construction before? So what do you build? You build the foundation, and then what else do you build?
Build out the framework.
Okay, so we will build the frame. Change this, and we'll say this will take 2 seconds. Okay, and then what happens after you build the frame? Electric, maybe HVAC and then electric, perhaps. We'll change this to maybe 3 seconds. Another one for building the electric. And this will take, let's say, 2.5 seconds. 2,500 milliseconds. Now what we can do, get rid of all this, is we can call things in a specific order to happen in a specific order. So first things, I'm going to build my foundation, then I'll build my frame, I'll do the HVAC, and then I'll do the electricity. Let me copy all of this to the screen. All right, so I have all of these different functions. It didn't blow up when I entered it. Let's run this code. Oh, what do you expect to see? Expect to maybe see, well, let's put some console logs in here. So maybe foundation built. Console logs, otherwise we don't know where we are. Foundation built, frame built, HVAC built, electric built here. All right, so what do you expect to see before we actually type this out? Like, what do you expect to see? I'm thinking foundation built, frame built, HVAC built, and then electric built, because that's the order that I have this in, right? So I expect that to happen like this. So let me copy all of this again, put it in its place, clear the screen, and run this. So we get a promise, foundation, frame, electric, HVAC. Something happened here. What happened? Yeah. Yeah, electric was built before HVAC, even though I called electric to be built after the HVAC. And because I put the timeout to be 2.5 seconds, it just kind of shoved its way in there half a second before the HVAC. This is not what we expect, because we told it, we said we wanted to build the foundation, then the frame, then the HVAC, then the electric. And this is the concept where, like, fat arrow functions are actually going to help us out quite a bit. So if I turn all of these things into fat arrow functions, then we'll see it happen regardless of the timeout in the right order. So if I run this, foundation, and it waits, frame, and then it waits, and then HVAC is going to run, and then finally your electric is going to be built out to your screen. So the concept of promises is basically saying, I heard you, I promise I will execute. You don't need to worry about it anymore. Like, I will do this in the background. So that's one thing that we do need to know for today. When you take a look at news site 3, so let's go to github.com/echo/news site 3. We've cloned this down. This little semicolon here, if you've been wondering what I was doing. I was inside of news site 2, so I decided to CD out one level, but I didn't want to type in everything one more time. So this is just how you differentiate multiple commands on one line. So I could do CD out, and then afterwards, another command that's going to run is git clone. So here I am. Let's run npm install. And once this is running, npm, the news site number 3 has an API built into it. So it's listening for different sort of requests that you're going to be making. Let's wait for this. Is everybody's resume all up to date? We went back and forth a number of times.
I have a meeting with resume guy
Thursday? Danny?
Yeah, we have one more meeting.
Yeah. Cool. Right?
Just changes you gave me.
Okay.
But done with Ben.
You're done with Ben?
You done with me?
You're done with Ben. Sick of him. I'm finished. The joys of Node Package Manager. As you can kind of see, this is taking a very long time. So people who are, web development professionals are like kind of displeased with just the speed that this is taking. So you may see something called Yarn pretty often online. Yarn is just another version of Node Package Manager that's just faster than NPM. So even though NPM is like hands down the largest package manager on the planet, like bigger than Ruby Gems, bigger than anything else, there's always someone who's going to try to come and eat your lunch. So Yarn came in as basically, people like it a little bit better. So when I run npm start today, you're going to notice two things. I'm running 2 servers. And I'll see it in just a second. I have a regular server living at 3,000, so I'm still able to make all my requests to localhost 3,000, and it's broken right now because I still have to copy everything over. But I also have an API listening at 3001. So if I were to not make an AJAX request because AJAX is out of date now, or we want to use fetch requests, maybe it'll look something like this. So first things first, I'm going to make my request to localhost 3001/API. Once I get a response back, I'm going to turn it into JSON, and then I'm going to console log it out to the screen. It says that we have the web server is listening at 3001, so we have an API right over here. Let's see if this works. So we'll go over here. So a lot of things are broken right now because I haven't copied stuff over from news site number 2. I'm going to make a request to 3001/API. Maybe I'll go to articles/2. So instead of it just living on one giant file, it lives on an API. So I'm going to make this right here. You can kind of see I made a fetch request to this particular URL. It returned me a promise. The promise is basically saying, like, I'm pending, like, I promise I will do something in the future. I acknowledge that you sent something to me. Go about your day however you wish. Once it finishes on its end, then I got a response in JSON. I took that JSON and I console logged it out to the screen. And this is what I have right over here, that Today in Mosul article that we had a long time ago. If I made it to a different one, maybe I make a request to the 6th article, and it returns me a promise saying, I acknowledge that you sent it to me. I will do it sometime in the future. And then once I got all of my response back, I turned it into JSON, and I console logged it out. If you take a look over here, it doesn't keep track of your requests, but it is actually listening and actually going to be returning things out to the screen to you. You're going to need to know all of this for news site number 3. When we take a look at news site number 3 today, again, it's not a ton of React code that's going to be happening. You're going to be mostly writing the API layer. So you're going to, instead of reading from news/JSON, you're going to go to localhost 3001/API/articles. When I go to that particular page, I make a GET request to 3001/API/articles. It still returns me all of the same stuff, but I'm not reading directly from one file. I'm making a request to this file, and they give me back all that same information. You're going to be mostly working in the article API.js. You're going to basically say, like, how do I, using different methods that I write, I want to be able to get information from the API. So when I enter in one particular, when I go to get an article based off of the ID or based off of a particular section, I want to be able for you to call out to the API, based off the response, narrow it down to ones that match. So I'm not using active record or anything like that. I'm just using the built-in JavaScript methods. So no active record or any sort of object relational mapping like SQLize. I'm just making a request to the API, and I'm going to dumb it down from there. It should be fairly self-explanatory, but this is a challenge in a different way. It's because we haven't really made real API requests before. I want to talk about component lifecycle, but I don't want to confuse people because that's a huge topic. So we'll talk about that tomorrow. So tomorrow morning, what we'll do is we will go over news site 3. I'll walk through the entire solution, my solution, and then we'll talk about component lifecycles and then move on to news site number 4. So my hope is that you can finish 2 today, and hopefully you can also finish 3, but definitely 2. Finish 2 by the end of today.